welcome to ESE Electronics. So today's video is a mock test of radar subject. So we are going to again resume the mock test series. We'll be doing mock tests for various subjects of electronics, especially for AFCAT exam, ISRO exams and for GATE exams. Okay. I've included 10 questions from radar from various areas. And if you found the video useful, please don't forget to like, share and subscribe. Now you can see the 10 questions. So this video is a mock test of the subject radar. A lot of people was asking me to do a video on mock test of radar. So here it is. I've included 10 questions which you have already seen, and now we are going to see the solutions. Okay. And honestly, there is not much questions over the internet from the subject radar, and you cannot find really much videos in the YouTube also. So I really hope that these questions will be helpful for you. Okay, so the first question, you can see the question on board. Which of the following is correctly matched? Option 1, R is proportional to PT raised to 1 by 4. So, R is the range. Is proportional to PT is transmitted power raised to 1 by 4. So, if you know the equation of range of a radar, I'll write the equation first for you so that it is easy to figure out what is the relation between the variables. Okay, so the range of radar, or you can call it is R max. R max equal to PT transmitted power into gain into sigma radar cross section of target into an aperture by 4 pi square S minimum detectable power, the whole raised to 1 by 4. So this is the relation. Now let's see the options. Not options. Let's see the 1, 2, 3 relations. First relation is R is proportional to PT raised to 1 by 4. It is correct, right? R max or R is proportional to PT raised to 1 by 4. That is a correct relation. So 1 is right. Now 2, R is proportional to PR raised to minus 1 by 2. No. You can also write this is the received power, minimum detectable signal or minimum received power, you can see. Okay, in some equations you will be writing here PR. When we want to find the received power, we will change it to PR also. Okay, so and what is the relation? Is R max or R proportional to PR raised to minus 1 by 2? No, that is not the correct relation. So option 2 is wrong. Option 3 is R is proportional to square root of D. No. Here again, you can write the aperture in terms of the diameter, but that is also not a correct relation. R is proportional to square root of diameter of antenna is also not a correct relation. So, the correct answer coming here is, I'll read out the options now. Option A, 1 only. Option B, 1 and 2 only. Option C, 1 and 3 only. And option D, all the above. So the correct answer is option A. Option A, only first. That is, first one is correct. First relation is only correct. That is, R is proportional to PT raised to 1 by 4. This is the relation. This is a very famous relation. We use it in a lot of numerical questions. Okay. Now, the correct answer for the first question is option A. Moving on to the second question. Second question is a numerical question. I'll read out the question for you. A radar operating at 5 GHz uses a common antenna for transmission and reception. Okay. The antenna has a gain of 150 and is aligned for maximum directional radiation and reception to the target 1 kilometer away from the radar cross section of 3 meters square. If it transmits 100 kilowatt, then the received power in microwatt is dash. So there's a lot of things said in the question. This is a second question. Okay. So there's a lot of things being discussed in the question, but our aim is to find, so what is being asked or what is the aim of the question is to find the received power. We are not interested in other things, but we'll be anyway taking the given details from the question. So the details given, I'll write it. F is a frequency which is 5 into 10 raised to 9 hertz. It is 5 gigahertz. Now from this you can find the wavelength C by F, 3 into 10 raised to 8 by 5 into 10 raised to 9. You will be getting it as 0.06 meters. You have obtained the lambda. Now the gain is directly given, it is 150. Sometimes the gain will be given in dB. Then you have to convert it to ratio. Okay. So these things you have to note. R max is also given 1 kilometer, or you can write it as 10 raised to 3 meters. Then sigma, radar cross-section of target. Sigma is the variable denoting that. It is 3 meters square. It is an area. Okay. Radar cross-section of the target means it is an area of the target which is detectable to the radar. Okay. Also, PT is given 100 kilowatts. So these are the details given in the question. Now, what is the equation? Earlier in the first question, we have discussed the equation in terms of S minimum. But I have said that there also, we can replace S minimum with received power. So the equation will get changed like this. I'll write the equation. R equal to PT G lambda by 4 pi, lambda square by 4 pi, G sigma by 4 pi square PR. Now there are some modifications in the equation from the previous equation. What all are that? I'll tell you. See, PT, okay, there is also a 1 by 4 outside. Okay, so this is the relation. Now R is the range, which is the same. PT is the transmitted power. Now we have replaced, there is one variable missing here. What is that? Antenna aperture. AE is missing, right? So we have replaced AE with this representation. AE can be written as A equal to lambda square by 4 pi G. Okay. Write it. AE equal to lambda square by 4 pi G is the representation for AE or antenna aperture. So I have replaced here AE with this. Okay. All the other variables are same. Also I have replaced S minimum by received power. Now you just have to solve this because all the variables are being given to you. And also PT, I will write it. PT equal to 100 kilowatts. Okay. So just substitute these values into this equation. First you have to remove this 1 by 4 and make R raised to 4. Okay. So this will be the relation. R raised to 4 equal to PT into G lambda square by 4 pi into G again sigma by 4 pi square PR. From that you will get what is PR. Okay. And if you solve it, the value obtaining is the value obtaining is 0.0122 microwatt approximately is the received power. PR is equal to 0.0122 microwatts. Okay. So the correct option is option B is the correct answer here. Okay. Second question, correct answer is option B. Okay. Now moving on to the third question. You can see the question on board. Yeah. The pulse repetition frequency of a moving target indicator radar is given as 1 megahertz and the wavelength of the carrier is 0.8 mm. Then calculate speed with which an object should move to avoid interception in meter square. So you have to find speed here. Okay, what all things are given in the question? Pulse repetition frequency, we denote it using PRF, 10 raised to 6 hertz, megahertz. Lambda is directly given 0.8 mm. Or you can write it as 8 into 10 raised to minus 4 mm. Sorry, not mm, it's meter. Then we need to find speed, and that speed is called blind speed, VBN. VBN is the blind speed. And the equation is pulse repetition frequency into n lambda by 2. Okay, we'll take n is equal to 1 and just substitute the other values here. PRF is 10 raised to 6, lambda is given to you by 2. The value you will be obtaining is 400 meter per second. The correct answer here is option C is the correct answer. 400 meter per second is the correct answer for option question 3. Correct option is option C. Moving on to the fourth question. I'll read out the question for you. So this is the fourth question we are going to discuss. The peak power at the output of radar is 1 kilowatt. The pulse width of the wave sent is 10 raised to minus 4 meter and the pulse repetition frequency is 10 raised to 3 hertz. The average power dissipated at output of the radar is dash watts. So what all things are given? Peak power is given to you, pulse width is given to you and pulse repetition frequency is given to you. You need to find the average power. Peak power is given, average power you need to find. The relation is, I'll write the relation first. P average power equal to peak power, P peak into duty cycle. So duty cycle is not given to you directly, but you can write duty cycle in terms of the pulse width and pulse repetition frequency. So the equation changes like peak power into pulse width is PW into pulse repetition frequency. Now all the values are known to you, right? So you can find average power. 10 raised to 3 into 10 raised to minus 4 into 10 raised to 3. That will be 10 square or 100 watts. This will be your, this is the average power for the, that is average power at the output of the radar, okay, which is 100 watts and that is option B. Correct answer for the fourth question is option B. Moving on to the fifth question. Yeah. For a radar, the power received by it after reflection from the object of interest is proportional to, in bracket is given, R is the distance between radar and the object, that is the range. The question is asking a relation between the power received by the radar after reflection. Okay, so what is the relation between received power and range? That is a simple meaning of the question. I'll write the equation once again for you. This equation should be very much thorough for each and every one appearing for all competitive examinations of electronics. Okay, very important equation, radar range equation. R equal to PT GT A sigma by 4 pi square into PR the whole raised to 1 by 4. Now you need to find a relation between R and PR. So we make, this is R raised to 4 and this is as it is. That is, we have removed the raised to 1 by 4 by taking the fourth power. Okay. Now how can you write the relation? PR equal to you take PR here, R raised to 4 will come in the denominator. PR is equal to 1 by R raised to 4 or proportional to, right? So the relation is simply PR equal to 1 by R raised to 4 is the relation, and the correct answer here is option C. Okay. So the fifth question, correct answer is option C. Now the sixth question is a theory question. So there are various types of radar, right? This question is relating to the type of a radar. So the radar question is the radar in which both the transmission and reception is done using the same antenna is called dash. A. Monostatic radar, B. Bistatic radar, C. Monopulse radar, D. Dipole radar. Correct answer is option A. If both transmission and reception is done with the same antenna, it is called a monostatic radar. Okay. I think in one of the previous questions we have discussed, there were same antenna was using for both transmission and reception. So that question is related to a monostatic radar. So these terms also you should be knowing. Correct answer is option A, monostatic. Now moving on to the, this question was question number 6. Okay. Now moving on to the 7th question. The 7th question is, an FMCW, that is frequency modulated continuous wave radar, is essentially dash. A. Bistatic, B. Monostatic, C. Can operate either as monostatic or bistatic, D. None of the above. So the FMCW radar is actually a bistatic radar. So in the previous question we have discussed what is a monostatic radar. Means the transmission and the reception is done using a same antenna. But if two different antennas are used for for transmission and reception, then it is called a bistatic radar. Okay, that is the transmitting as well as receiving. So the 7th question is, a FMCW, that is frequency modulated continuous wave radar, is essentially dash. A. Bistatic, B. Monostatic, C. Can operate either as monostatic or bistatic, D. None of the above. So if a radar is using same antenna for transmission and reception, it is called monostatic. But here FMCW is actually a bistatic radar, means it has both transmitting and receiving antennas separately. Okay, so the FMCW is actually a bistatic. Correct answer is option A. Now there are some features for FMCW radar. They are having shorter ranges and very low power requirements as compared to the pulsed radar. Okay, so that is one feature of FMCW radar, that is frequency modulated continuous wave radar, and it is a bistatic one. Okay, moving on to the 8th question. If range of a radar is to be doubled, the peak transmitted power of the radar has to be dash. Again connecting to the radar equation relating the parameters or the variables. A. Increased by a factor of 2. B. Increased by a factor of 4. C. Decreased by a factor of 4. C. Decreased by a factor of 4. D. Increased by a factor of 16. So here we are actually we are changing the range. If the range of a radar is doubled, how the peak transmitted power is affected? That is the equation. So what is the relation? R is proportional to PT raised to 1 by 4, or you can write PT proportional to R raised to 4. We have changed it by taking the 4th power. Okay, so this is the relation between the transmitted power and the range. So we'll write it in terms of ratio. PT1 equal to R1 raised to 4, and what will be PT2 is equal to 2R1 the whole raised to 4. You can write it as 2 raised to 4 dot R1 raised to 4, or you can write 16 R1 raised to 4. Now what is R1 raised to 4? It is PT1. PT1. So PT2 will be 16 times PT1. That is a relation. Or you can say it is increased by a factor of 16. Correct answer is option D. Okay. Now moving on to the 9th question. I'll remove this. I'll read out the question for you. Yeah, 9th question. The maximum range of a monostatic radar is R. See, when while answering the numerical questions, also you have to identify these wordings like monostatic radar, FMCW radar, pulsed radar. These are various types of radar. Okay. So the maximum range of a monostatic radar is R. If the target having a radar cross section of 10 meters square exists at R by 2. Okay. So there is a target of sigma or radar cross section of target 10 meters square and it is existing at R by 2. What should be the target cross section at 3R by 2 to result in an equal strength at the radar? Okay, so this question is connecting to range and radar cross section of target. So we have to write the relation between the radar range and cross section of target. So R is proportional to sigma raised to 1 by 4. I'm really hoping that you have noted the radar range equation. I have already written it multiple times in the same video. So just take the relation simply. R is proportional to sigma raised to 1 by 4. Now, I'll read out the question for you. If the target have a radar cross section of 10 meters square at R by 4. So the first relation, at R by 2. So the first relation is R by 2 at R by 2. The value of sigma equal to 10 meters square. Right. Now, it is asking what should be the target cross section at 3R by 2. At 3R by 2, what is the sigma? This is the question. Now, in order to find this, we have already the relation between R and sigma. We just have to take the ratio. So, we'll take the ratio simply by dividing R by 2 by 3R by 2 equal to 10 by sigma nu we'll write. Okay, sigma nu. We don't need any units because all units are same for this ratio and this. Okay, so R by 2 by 3R by 2, if you take, it will be 1 by 3. 1 by 3, okay, I'll write it once again. So R by 2 by 3R by 2 equal to 10 by sigma, the whole raised to 1 by 4. The relation is not just equal, it is raised to 1 by 4. See, R proportional to sigma raised to 1 by 4. So if you take the ratio also, the ratio will be R by 2 by 3R by 2 equal to 10 by sigma nu, the whole raised to 1 by 4. You have to follow the relation also. Okay. Now, R by 2 and R by 2 cancel. 1 by 3 equal to 10 by sigma nu, the whole raised to 1 by 4. Again, we are going to take the fourth power and it will be 10 by sigma nu. Now, sigma nu equal to 10 into 3 raised to 4, or it is 810 meters square. Correct answer is option C. Okay, I really hope you understood how to do this question. See, the question was asking at one range there was one sigma. There is one target of cross section of the radar cross section of target. At another range, they are asking what will be the sigma value. So you just have to first find the relation between the range and the sigma and then take the ratio. So that's what we have done here. We have obtained the value as 810 meters square, which is option C. Correct answer for 9th question is option C. Okay, now we are going to the 10th question, which is the last question that we'll be doing. Yeah, 10th question. It's a theory question. The Doppler radar works by measuring the dash of the reflected radio wave. So we know that the principle of radar is sound wave reflection, or simply electromagnetic radio wave reflection. Okay, that is, it sends a wave, the wave hits on a target, it then waits, the radar waits for the echo, which is the reflected wave, and then it measures the time difference between the send wave and the received wave, and then it try to figure out where the target is actually present. Okay, so this is the principle of working of a radar. Now this question is asking the Doppler radar. Doppler radar is actually working based on the principle of Doppler effect. I've done a video on the Doppler effect, actually discussing some questions. So in the radar playlist you can find various videos on radar numericals and some quick revision. Okay, so the Doppler radar works by measuring the dash of the reflected radio wave. A, intensity, B, frequency, C, Doppler amplitude, D, Doppler shift. Correct answer is option D, Doppler shift. It is measuring. Okay, so these are the various types of radars. I'm telling it once again, in the radar playlist you can find quick revision video on radar subject. That is what all things you need for a competitive examination. I've done the video on that point of view. Not all the theory things have stuffed into that video. Okay, so and also I'm telling it once again, you cannot find much videos on radar, numericals and quick revision over the internet. So I really hope that this video was useful for you, for your preparation. The questions were good enough for your preparation. If yes, please do give it a thumbs up and also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.